this lesson. Alright, so let me take you through this part where we have consider triangle ABC as shown at this point here that I've highlighted. So they are saying that consider triangle ABC as shown. Okay, triangle ABC as shown. They are saying that angle BAC is theta. So this is the angle here. In other words, this letter A is where the angle is. The letter in the middle, that's where always the angle is. So the triangle was A, B, C, but angle BAC. So they are talking about this angle here, A. Angle A is theta. Side BC, so this is BC, it's opposite to the angle theta, and side AC is adjacent to the angle theta. Let me try to see if I can minimize that. It's very hard. So now when you look at that triangle, if I may try to draw it for you and then explain for you what is opposite, what is adjacent, what is the hypotenuse. I know some of you studied this, but they have said that this is A, this is B, and this is C. So this is where we have the angle theta, that point. So this side here, CB, when you look at CB, if we have someone standing here, or someone, let's say someone is standing at this point where the angle theta is, and is looking at this side. If someone looks at this side, what does it mean? It means that looking at this side, which is here. If another person is standing here, and is looking at this side, it means that this person is facing at this angle here. So what does it mean? It means that this side here is opposite to this angle. So in other words, they are opposite to each other. This side is opposite to the angle. So that's why we call this side here the opposite side. It is the opposite side to the angle. Together. This side is the one which is opposite to the angle. And then this base which is here, this base which is here, that you're seeing, CA. So this is the, we know that this is the hypotenuse. Everyone knows this from the Pythagoras theorem, that this is the hypotenuse. This side BA is the hypotenuse. Then this side, the base, where the foot of the angle is, if this is the foot of the angle here, then this base here is what we call the adjacent. It's what we call the adjacent. So this side is opposite to the angle, this side is adjacent to the angle, and this one is obvious. This one is the hypotenuse. That's the hypotenuse. Okay, now if we are to find the tan of, say, this angle which is here, theta, the tan of that angle. So the tangent, say tan, because tan comes from the word tangent. So the tan of this angle, theta is a Greek letter, theta. It's just a letter called theta. So the tangent, the tan of theta is given by the opposite side. So it is the opposite side divided by the adjacent. So if you have value of the opposite maybe 3 centimeters, and you have the value of the adjacent maybe 4 centimeters, you can get the tan of the angle which is here. So this is what is very important for you to know, that if you want to get the tan of an angle, it is the opposite divided by the adjacent. The other thing, that most important thing also, that how do you know that this is opposite? How do you know that this is adjacent? So you look at the angle. If you want to know where the adjacent is, look at the angle theta. Then always the angle is in between two sides. It is in between the hypotenuse. It is also in between the adjacent. So what you have to do is, the angle is always in between two sides, the hypotenuse and the adjacent. So the hypotenuse can be easily seen because it is a slanting side, and then the adjacent is that angle on which that side on which the foot of the angle is. So it comes from the word being adjacent. So this side is adjacent to the angle. Then the other side that is far away, that is not connected to the angle, because you see this side and this side, there is an angle in between them. But this other side, there is no angle theta in between them. So it is far away from theta. So this side which is far away from the angle theta is what we call the opposite side. Together, members?
Yes.
So if you have a question, you can just put up your hand and then I can see. Okay. Now let us proceed. We have an example here. This example says, name the sides which are opposite and adjacent to the angle marked theta in each of the following. Name the sides which are opposite and adjacent to the angle marked theta in each of the following. Let me start with C, part C. Let me start with part C. So if I may draw how part C looks like. So this is where the angle is. The angle is there. This is V. Part C. This is V. This is U. And this is W. So the angle theta is here. The angle theta is there. So they have tried to alter around the shape of that triangle, but we know where there is 90 degrees, where is 90 degrees, if I may go back here, where we have 90 degrees, 90 degrees is between two sides, the adjacent and the opposite. In the adjacent and the opposite. So for us to figure out which side is this, which side is this, which side is this, let us first look at where 90 degrees is. 90 degrees is here. So it means that either this is adjacent or this one is opposite. Are we together?
Yes. Yeah.
So either this is adjacent or this one is opposite. Why? Because we have said that the sides which are in between 90 degrees, one of them is opposite, another one is adjacent. Now, when we come back to this diagram still that we did previously, we said that the side that is far away from the angle, this side that is far away from the angle, But remember this side, it's where 90 degrees has 90 degrees here. So we have this side and this side. But this side, which is far away from the angle, because the angle is this side, and we have this side far away from this angle. So this side is the opposite. That is the opposite. Now let us try and see which side is opposite here. So we have the angle here. We have said either this or this is opposite. So this side, which is far away from the angle, this one is the one that is going to be opposite. So this is the opposite. And we know that now there are two sides. One must be opposite, another must be adjacent, but in between them is 90 degrees. Excuse me. So it means that this one is adjacent. Okay. Let me ask Sandra, are you there? Sandra, unmute. Sandra, unmute. Sandra. That's Sandra. Sherry, let me ask Sherry, your piece has a problem. Patricia, which one is the hypotenuse now? Patricia?
UW.
So UW is the hypotenuse. Hypotenuse. That is the hypotenuse. So get in mind that the sides that have an angle of 90 degrees in between them, one is opposite, another one is adjacent. But that side that is far away from the angle is opposite, because the angle is here. Now that side that is far away from the angle, this side, this one here is the opposite. Then this side becomes the adjacent. Then this one is the hypotenuse. Okay, so let us go back to our exercise here, and I'm going to ask each individual. I'm going to start with Sherry. Sherry, your microphone is not working, but at least you can chat with us and you give us the answer. I'll be able to see it. So Sherry, on part B, this is where the angle theta is at P. So which side is opposite? Sherry, which side is opposite? You can text us the answer. Sherry? Which side is opposite? Opposite PR. Now, any slanting side. Do you see any slanting side? Any slanting side is the anything. Now, this side PR, Sherry is telling us that it's PR.
Hypotenuse.
PR is the hypotenuse, isn't it?
Yes.
Members, you can unmute all of you. PR is the hypotenuse. Sherry.
Yes.
Sherry, I think you have seen that PR is the hypotenuse. We have said that there are two sides. We have this side and this side QR. Between these two sides, QR and PR, one of them is opposite. Why? Because they are separated with 90 degrees. They have 90 degrees in between them. So one of them is opposite, another one is adjacent. So we are asking for the one which is opposite. The one which is opposite, if you look at this part A, the one which is opposite, it was AC. S was the one which was opposite. Alexandria, first wait and explain. So the one which was opposite was SC. Why? Because SC is far away from theta. In other words, if someone is standing at SC here, that person, if it's facing towards this side, it will face at this angle theta. So that means that theta and this side SC are opposite to one another. So SC is the one which is opposite in this case. So now that's why I'm coming back here. Which side is opposite? Esther, that is not right. Thank you for trying. Someone who knows the answer? Of course, it's going to be automatic. That is going to be QR. Isn't it? Because QR, QP. So what is QP? What is QP? Yes, Cynthia, what is QP?
Adjacent.
QP is
The adjacent.
QP is the adjacent, correct. I hope everyone is following. If you are not following this, you have to know this fast. I will spend, I can even spend more 5 minutes for you to understand which one is opposite, which one is adjacent. Because that's what you have to know in trigonometry to do the sine and the cos. So if you have not got it very well, you can put up your hand and then I can see you that you need help. Okay, so let's go to the next question. Next question is part A. Part A. Let me ask. I'm going to ask someone here. Esther, you've just joined in. Esther, Inach, you've just joined in. Are we at par? Inach, are we together? Now to connect your microphone very well. Sherry, I don't know. Mwesugwa Romeo, unmute. What is adjacent on part A? What is adjacent to theta? What is adjacent to theta? Mwesugwa Romeo, speak up please. Yes? Mwesugwa, don't run away from your question. Say something, please. Okay, Mwesugwa, you are just there smiling now. Okay, let me ask the last one. Yeah. That was Esther, Alexandria. So which part is that adjacent on AB?
Is AB.
It's AB, correct answer. So it is AB. Okay, it's AB. All right. Mwesugwa, AB is the one which is adjacent. Why? Because AB is the side that is next to the angle here. For it, it is adjacent to the angle. So this is the angle and this side is adjacent. Then this one here, it is opposite because it is opposite to the angle theta. Okay, this side AC is the CB is the hypotenuse. Okay, so let us go to number 2. Number 2, what are they saying? Number 2, they are saying that express tan theta as a fraction of each of the following triangles. Express tan theta as a fraction of each of the triangles. So there we are not going to find the actual answer of tan theta, but they want us to express the tan theta in terms of a ratio, in terms of a division, this divided by this, full stop. So let me start with part C. Let me start with part C. I'll show you part C. So part C, which is there, is number 2, part C. So we have a triangle. So always a right angled triangle will be labeled by that. Once it's not there, then it's not a right angled triangle. So this has to be there, and then you understand that you are dealing with a right angled triangle. So part C, this is 80 meters. 80 meters. This is 52 meters. Very easy and cheap. So they are telling you to find tan theta. So to get tan theta will be given by the opposite divided by the adjacent divided by the adjacent. So tan theta is equal to the opposite. So the opposite here, if this is theta, this is my hypotenuse. And this one now, this is the angle. We have this side and this side. So one of them is opposite, another one is adjacent. So this side, which is far away from the angle, is the opposite. And this one, which is here, automatically becomes the adjacent. So the opposite is going to be 52 out of the adjacent, which is 8. So tan theta, you can reduce that. You can reduce that. You shall have 52 divided by 0.65, but you want it in a fraction, so press shift, get to that. So you get 13 over 20. So 13 over 20 is our answer. Oh, someone has not said something. I'm going to pablo on you until you say something. Sandra. Sandra, unmute. Okay, Sandra, good morning.
Good morning.
Sandra, we are looking at this exercise. Have you been following?
No, today is my first time.
And this is also the first time to study this topic.
Yes.
Maybe you can try. Don't mind, you can try. B. Can you give me tan theta of part B? Can you try? Tan theta is equal to?
Opposite over adjacent.
So tan theta, this is. Okay, so tan theta is equal to?
Opposite over adjacent.
Over adjacent. Okay, so what is opposite?
9 meters.
9 meters out of?
5 meters.
So your answer becomes 9 out of 5. 9 out of 5. Members, this is very good. Sandra, thank you very much. Let me clap for you. All right. So now, thank you very much. So the answer 9 over 5. So they want it in form of a fraction. There's no need of getting it in decimal places. You leave it the way it is. For the time being, for just this first subsection we are looking at. Later on, we can see what we shall do. Okay, so members, let me ask you lastly, part A. Who was the answer? Part A, what is the ratio? You can put up your hand, the first one to put up the hand. What is tan theta? Yes, Sherry. Sherry, you are going to type. Sherry, can you type that? Sherry, your microphone, we can't hear you. Sherry, are you typing? Okay, but 48 over 16 is, okay, 48 over 16. That is correct. And then when you simplify, you get 3. You get 3 out of 1. That is correct. Thank you very much. So members, this lesson is left with 4 minutes, but with those 5 or 4 minutes, we can proceed and look at something else. Okay, I'm going to just teach you something very small here until we proceed to another part. So, if you are given an angle, let's say 12.8 degrees, that angle there, 12.8 degrees, 12.8 degrees. And you want to change that angle in terms of degrees and minutes. So what do you do? Degrees and minutes. So what do you do if you want to change that? So what you have to do there is, you know that this one here is 12 plus, and this 8, this is 0.8, so it is as if it is 0.8. So 12, we are going to separate 12.8, we separate 12.8, we get the whole number alone and also the decimal alone. So the decimal is 0.8, but the whole number is 12. Okay. Now what we are going to do is we get 12, and then we get this 0.8, the 0.8. So we shall get the 0.8 and multiply it by 60. I have 12, so 0.8 multiplied by 60.
48.
48. So we get 48. So here we come and write that it is 12. It is 12. Now here we're not going to add, we are going to say 12, 48, 48 minutes. Let me repeat that one for you.
Yes.
So we want to change 12.8 to 12 degrees and minutes. So what we do is we separate the whole number alone, also the decimal alone. So 12 plus 0.8, you get 12.8, isn't it? Which is here. We multiply it by 60 because we know that 1 minute has 60 seconds. So we multiply by 60. So when we multiply by 60, we get 48. So now we write 12 and and for 0.8, we say 12 and 48 minutes, like this. So you can be given an angle 12.8 or 12.48 minutes. So this is how we can change this angle to this. This decimal, we divide by 60. Here 0.8 divided by 60. Suppose you have, let's say, 13.48 degrees. So we shall get 0.48 and multiply it by 60. So what we shall get, if we have 0.48 times 60, so we get we shall have 28.8 altogether. So we shall have 13. We shall have 13 degrees, 28 minutes, and then 8 seconds, something like that. We shall do more examples about this in the next 40 minutes to another thing. So if the lesson ends, you go back and